Now, port channeling is a very famous layer 2 optimal utilization of bandwidth. A layer 2 solution for optimal utilization of bandwidth, complete utilization of your resource. Spanning tree blocks port. By blocking port, you achieve a loop-free layer 2 network, there is no doubt. But there is a cost that you pay for it. But you cannot use all the available links. The standby link has got the bandwidth. Standby link has got a port. Standby link is connected to some switches. Standby link, you have paid money for that link, which you are not able to use. So only the primary path is used. If I have 5 alternate paths out of 5, only one I am able to use. The other 4 are idle. I'm unable to utilize the all available paths, which is solved by this port channeling. So whenever you got multiple paths between two switches, this is the condition. Whenever you got multiple paths, multiple links between two switches to reach some devices behind the switch, when you run spanning tree, only one link is going to be available, only one path is going to be available. When you use port channel, you can use all of them. When you have 5 links between two switches, you can have all 5 of them. If each link is 100 meg, with spanning tree you get only 100 meg, but with port channel you can have 500 meg, because all 5 are bundled as one logical link. If you got 5 links as 5 separate links, physical links, separate as it is, then BPDUs will tell spanning tree that loop is going to occur because they have separate switch IDs, separate port IDs, separate STP cost, and spanning tree will go and block 4 links out of 5. But when you bundle them, when you bundle all the 5 links between the switches as one link called port channel link, sorry, when we bundle all 4 links as one virtual link, we call it as port channel. Now if each link is 100 meg, you get all 400 meg, losing nothing. Even here the loop is not possible because it is not for, though it is for physical link, it is one link according to the switch, because you are going to virtualize them. This is port virtualization. This is port virtualization. You take 4 links and bundle as one single link, which is a virtualization. switch will see it as one single link, and when it tries to send the packet out, it will spread the packet via all 4 paths by hashing it. So the packet reaches early. In another word, you increase the speed because you got all the links available now. Spanning tree, it was slow, only 100 meg. Now you got 4 times speed between these two switches, 4 times more speed. Aggregating, bundling, aggregating. Condition is both need to be having same link port type, port speed, both the side. All 4 links need to have same duplex, same speed. One side cannot be gig Ethernet, another side cannot be a fast Ethernet. And no ports on this should be a span port. Span we learned, switch port analyzer, nothing but port mirroring. None of this port should be a span port. See, if you want to span, if you want to mirror, you can mirror the traffic of this port channel, of this bundle, but not the traffic of one single port in the bundle. You cannot span one particular port of this bundle, but you may span the entire bundle's traffic. Another condition I said, speed, duplex. Type, meaning all 4 can be a trunk or all 4 should be a axis. If it is trunk, on either side, the allowed VLAN should be same. Yeah, these are the conditions. Now, when we bundle these ports, unique identity is removed and a common identity is given to this bundle interface. The MAC addresses of these ports are no more valid because they are no more individual interface. So a MAC address of this bundle, one of the link in this bundle, I repeat, the MAC address of one of the link in this bundle is dynamically picked and given as a MAC address of the bundle. So your port channel still have got the MAC address to get identified. It's not 4 MAC addresses, it's just only one, any one on this bundle. Mostly it will be the first interface in the bundle. Mostly I have seen that. The first interface that you configure under the bundle, that interface MAC address is going to be copied as the MAC address of the bundle. Okay, so there's the logic here. You see, you got only one port ID, even though you got 4 physical ports. Now, when you configure port channel, they are ready to consider this 4 port as one port. and the port channel comes up. This is what called as on mode. Just the port channel comes up. On either side you configure, and both the side they support this because everything is properly configured by you. There was no problem, no malfunction, everything goes fine. But what if I misconfigure? Then it is going to cause some unexpected results. Malfunction. So on mode is not a recommended mode. On mode is going and configuring port channel on either side without using any protocol to negotiate. Without using any protocol to negotiate. You just go and turn on, hoping that this 4 wire other end is also configured here as a member of that bundle. But what if you mistakenly left this interface? This interface is connected here. And you took some other interface and put it in the bundle on the other side. In this switch side, this is in the bundle, whereas on switch 1, that port is not, that wire is not in the bundle. Likewise, this wire, here it is in the bundle, here it is not in the bundle. You thought that you configured correct, but it's not correct. So port channel is not going to work normal as you expect. To avoid this, what we have to do? We need to depend on a protocol. There are 2 protocols available for this. One is LACP, the other one is PAGP. LACP stands for Link Aggregation Protocol. See, basically you aggregate links on either side. And this LACP goes and checks whether the links of this side is also configured inside the bundle on the other side. It goes and checks it first before bringing the port channel to operational state. It goes and verifies with the other party, other side, whether the other end of the same wire is also there in the bundle. If yes, only then the port channel feature comes up, otherwise it will stay down. They all will work as an individual device. STP will be the control plane protocol there. But when both the side is properly configured, the protocol will understand that there is no need for STP because we are going to consider this as one bundle. And STP goes off from there, and the port channel is now in operational, both the side. Yep. So both the side, after negotiation, the port channel comes up if you enable protocol. If on mode, there is no negotiation in first place. In on mode, there is no negotiation in first place. All right. So you can use any one protocol, LACP or PAGP. Only the difference in these two is LACP is industry standard. PAGP, which is Port Aggregation Protocol, is Cisco standard. Right. Other than that, there is no much big difference between these two. Yeah. So for LACP, the modes are called as active mode and passive mode. If it is LACP, one side you can keep active, the other side it can be passive, nothing wrong. But both sides cannot be passive. You may have both side active, no problem, because the active side is what initiates the negotiation. If both side active, that is also good. That's what Nexus people will do, data center people will do. There is also a command called force, what Nexus people do in data center. That is to add a new interface to the bundle. When you add a fifth port to this bundle, after configuring, there are chances that only that 4 port still continues as a bundle member. In order to make the fifth port to become a member, we use the keyword force so that the algorithm will reset and gets this fifth guy also into on board. So LACP active mode and passive mode. In PAGP auto mode, passive mode is called as auto and active mode is called as desirable. That's all. You need to configure and see. Do you know how to do this lab?
I've done it some time back.
Try this, and then if you face any difficulty, let me know. Right, layer 3 is going under the port channel interface and saying no switch port and give an IP address. That is layer 3 port channel, where it starts supporting layer 3 ping and so on, layer 3 IP address and so on. That's simple. Go to port channel interface and say no switch port. That becomes a routed port where you can give IP address, and that port channel becomes a layer 3 port channel. Right, and in order to have routing, you need to say IP routing globally so that you can have protocols like EIGRP and so on. Try this once, and if you face difficulty, we'll have this chapter once again, the lab portion of this once again in our next class. Any question?
So when you said like auto and desirable, so basically there are 4 modes like active. It can be active, the port channel comes up, and active, passive, port channel is up. And if it is on, even if that the port channel comes up. Passive, if you configure passive port ends, the port channel is down. It doesn't come up, is it?
Yeah, because they don't negotiate. They don't initiate the negotiation. Likewise, auto, they don't initiate. Dynamic, desirable is okay. Desirable and auto is okay. You cannot have auto, you cannot have passive. Any other question? Okay, I'll also give you a video of our previous recording on the configuration side. In case if you get struck when you do the lab, you can verify and correct yourself. All right.